I guess the first question I want to ask is quite a broad one, but what do you think parents misunderstand about math?
Math is a really challenging subject for a lot of people, parents or not, right? Math is challenging because we have this like very narrow idea of who can be good at math. It's like you got to be fast and you got to memorize things and you got to be able to like basically know it before the teacher even teaches it. When I ask kids like what being good at math is, they say things like that, and adults have the same idea that math is about speed and it's about memorization. And that's only a very narrow group of the population that can be good at that. And so when we're talking about neurodivergent kids, when we're talking about kids who take more time to learn, kids who have different ways of getting there, then it's even more challenging, especially if math classes are really narrow at how you can be good at math. They only have a few ways you can demonstrate understanding, only one way to do it correctly. That's particularly challenging, I think, for students with disabilities. The Gates Foundation just did a survey of parents, and they asked about what's the most important topic in school, and math was the most important topic. And it was the topic that parents said most needed a total change. They said in the survey that in general, what they wanted to see from math classrooms is they were more engaging. The kids would be more motivated to do math. The kids would see math as relevant to their lives, and so that's what parents are looking for in general. And I don't think parents with disabilities are parents whose kids have disabilities are any different. But math is just really challenging because we have certain ways of teaching it that are sort of don't work for most of the population, in my opinion.
Can you tell us a little bit about those standards of practice and like how that can help a parent understand what their child should be working on?
So the standards of mathematical practice, or the teachers call them SMPs, were designed in a collaboration when they wrote the Common Core State Standards between mathematicians and math teachers and math researchers. And they're basically how you engage in math, not what you're learning, say multiplication and subtraction, but how do you math? How do we math? Like, what is it that when we're mathing? And not just like when we're little kids doing math, but when we're like, how do mathematicians engage in mathematics? So the first one is my very favorite, which is to, number one, make sense of problems and persevere in solving them. And that is my number one most important goal for students, because when you present a challenging problem to students, something that's they don't know the answer right away, they need to take a little bit of time to think about it. Ask a friend, start visualizing it, use some manipulatives. This is a basic practice in mathematics. We want to be able to give kids problems that they don't know what to do right away, because that's what math is. Everybody gets stuck in mathematics, including mathematicians. What do you do when you're stuck? One of the, I did a study on dyslexic mathematicians. And one of them told me that he thought his dyslexia helped him in math because it taught him how to keep going when he was stuck. Like, he's like, when you're dyslexic and you're dealing with a system that's not designed for you, you know how to keep going, you know how to work around things. And that's what helped me become a mathematician, he said, because that's what you need to learn how to do. This problem is challenging. I am going to keep working and I'm going to find a way through it.
So how do those SMPs, the standards of mathematical practice, how does it fit with it?
When we think about the design of how we're writing math goals and objectives, when we start incorporating and thinking about the standards of mathematical practice and how we can connect those to the IEP goals and objectives, we're creating a more inclusive IEP where the student and the teacher kind of see a connection with, like, okay, this is what I have to build within the student to build the sense of belonging within that math community. Mm-hmm. And I have just found with teacher after teacher, learner after learner in this district, when the IEP includes objectives that are connected to these SMPs, it is more relevant. It creates a more relevant math learning for the student and connected to what's happening in the classroom, versus if we get very focused on these discrete skills. So what I found is, like, if you have a student in gen ed and they have a skill that is very different than what's happening within the general education curriculum, and it cannot be naturally embedded, that it does create this very disconnected feeling with instruction. And then the question comes up of, well, when am I supposed to provide this instruction when it is so not connected.
Yeah.
But that's why if you build in the SMPs, depending on the student's needs, if you connect them, it becomes this conversation of like, oh, I can do that. So
Right.
it's been really interesting. And so it's not every objective that I do that. It depends on the student and it depends on what the goal is, for the student. But it's been one that we've seen a lot of just promising results for programming and making programming decisions for students in gen ed.
I really like your maths criteria that is spelled M.A.T.H.S. Could you explain that a little and maybe like give us an example of how you would apply it to a goal?
It's a question I get all the time. And so I'm thinking, well, what do I think about when I'm thinking about if a goal is good? And so I tried to make an acronym to help. So the first is math. So it's maths, 5 things. The first is that it's measurable. And being measurable is super important because we need as teachers, and I was a special education teacher and inclusion teacher for 10 years. So I was a teacher for a while. And you need ways, you need to be able to collect data on whether the student is improving in this area. And it needs to be a way that you can collect data that works for you as a teacher, because teachers are very overburdened, right? So it needs to be measurable and also in a way that kind of works and fits with the way the teacher is working and the student. It needs to be ambitious, and ambitious is a word we use in math education. There's a word called ambitious, it's science too, ambitious science and math instruction, which basically means we're really trying to engage kids in mathematics and science, not just at sort of lower levels of maybe memorization, but the highest level of engagement. So in science, we're trying to get them to like do experiments and create experiments. And in math, we're trying to think about engaging all students in problem solving, thinking visually with mathematics, all of these things that math is really fun and engaging. We don't want to wait to do that stuff until kids are in college. We want it to be part of kindergarten on. So ambitious means that it's towards a really like challenging level of mathematics for all kids. Towards access is the next one. And that's to keep in mind that IEP goals really are not just about learning one content thing, one small narrow thing. They are supposed to be towards access and participation in general education. So we have to think about whether the goal is going to be useful to help a child participate in general education. And often goals in mathematics are like 3 grade levels behind. And sometimes like they're not about the math that child is going to be engaged in the general education. And this is really problematic because, and parents need to understand this, if your goal requires your child to be pulled out to get instruction, you are creating a situation where the child's going to be pulled out to get instruction because now the teacher is legally required to follow that goal. So in the example, I have a book that has a chapter on writing IEP goals. And in it, I think back onto this child that I worked with when I was a classroom teacher. And he was a 5th grader. He came to me with a goal on subtraction. And while I think subtraction is really important, as a 5th grader in my class, which was a full inclusion, no pullout unless I needed to pull him out for IEP goals, I believed I needed to work on fractions with them because it was more important and more likely to engage him in the class. Like if I'm working on subtraction, the class isn't working on subtraction. I have to find some other way, hand him a calculator. I need to be moving on and making sure that I'm working on the math content that's going to help him engage in the math classroom. So the next one is high leverage practices. This is the H. And there's 2 parts here. And basically like, is it worth your time is the question I want them to ask here. And that in general is kind of like the question I think parents should ask. Is this goal worth my child's time and your time as a teacher? So a high leverage goals means we're picking either, if we're going to do a math content standard, we're picking that content area that's super important, super high leverage. So fractions, for example, predict achievement in algebra. Fractions in terms of understanding like equivalent fractions, that becomes important in math all the way through. That's super high leverage. Understanding the number line is very high leverage because it predicts achievement all the way down the line. And the number line is a model that's used all the way down the line, right? So we pick a content standard that really matters or a standard of mathematical practice that we really think will be high leverage. And then the last one is S, stakeholder input, meaning that really good IEP goals are not made alone. and they're not made before the meeting. They're made in discussion and collaboration when we're collaborating with parents, when we're collaborating with general education teachers and special education teachers, and we're really trying to figure out what wasn't the weakest point in the Woodcock-Johnson and then make a goal about that. But like, what is really needed and what do we all want? What does this child want, hopefully?
When a child is like in a separate classroom and what we know is that they have unambitious goals, right? That very often the goals provided for math are counting over and over and one-to-one correspondence. And because often the IQ test shows that the child does not understand one-to-one correspondence, right? And so then they say, okay, if they don't understand that, we have to understand that before we can do any other math, right? And so that's what they focus on forever and ever. So is there a way to use your maths acronym to kind of try and get that goal to be a little bit more ambitious?
Dr. Paolo Tan, who's a colleague of mine. So he's a professor in math-ed and disability studies, and he also is a parent of a child who had significant support needs, who does and has autism. And he himself, even being an expert in these areas, had a lot of challenges in dealing with low expectation goals for his student. And he tells a story about in one IEP meeting in 5th grade where the assessment of the school showed that the child couldn't identify one-digit numbers. But he knew that wasn't true because he lives with this child and works on math with the child all the time. But yet faced really resistance in the meeting towards that was the goal that was proposed by the school. And he was like, no, my child already knows how to do this. But what he did to really break the sort of log jam, that kind of like professional log jam that occurred there, was he said, what are our goals? Like in math, what, not just this identifying digits. What do I want for I'll tell you what I want for my child. I want my child to engage in mathematics that makes sense to him, that's meaningful to him, to learn to do things that are going to be helpful to him in the world. Like I have these big goals for him, and these little goals are not going to cut it because this is where I want to go. And that's when the rest of the team was like, okay, that's where we want to go too. Like, well, let's all go there together. So my first thing, and this is, from his work, Dr. Tan, is that it's about like creating a collective vision of where we want that child to go. And I think this is particularly important for students with significant support needs, because the whole team has to say, we have a vision of where we're going to go here. And mathematics is not just this like small memorization thing. Math is a part of this vision. We want kids to be able to go to the store. We want kids to be able to fill out time cards. We want kids to be able to think about mathematics and hopefully understand statistics that are presented to them. Like making a bigger vision of what math is and what math can be is a part of getting goals that are higher, that are towards access, that are high leverage goals. So one thing parents can advocate for is is everybody in the school being included in professional development in math? Everyone together, special educators and along with general educators, so that we can use their expertise together. So this is something I advocate for. We have a class at my university, UC Santa Barbara, that's math methods for special educators. It's their own class where we focus on mathematical development so they can understand how kids learn how to count, and all the way up to, say, algebra and beyond. So that's one important thing, is to understand the content. And you can also, because if the special education teacher changes the way they teach math, then the goals will also change. So either one can be leveraged. Let's change these IEP goals to make them more meaningful, more high leverage, but let's also change the math instruction so it's more focused on what students know, more focused on problem solving. The two will influence each other.
Sometimes the schools don't want them to have calculators. Sometimes it's the parents that don't want them to. What do you need to know about adding a calculator? Like if you have a calculator goal, where do you start with that? And is there anything to look out for?
One of the things that is a learning curve for many of our teachers is to say, starting in really end of 2nd grade, before they get into 3rd grade, we need to be stating, do they meet the criteria for that? and can they get that accommodation? And we have teams that are reluctant to consider that because we want to delay the use of a calculator to give them continued time just on that normal sort of progression of building fluency with single digit. I totally get that. However, for some of our students with disabilities, I would say that what we need to be considering more is those tools, because the tools are what is essentially reducing that barrier, right? That we're leveling the playing field for the student to engage in grade level math with the tools. I'm okay with, and I'll talk with my teams about not giving them the calculator in third grade. Just make sure they have the tools. Make sure they have the number line. Make sure they have the fraction bars. Make sure they have counters. Make sure they have the hundreds chart, the addition chart. Let them have those things. Put them in the box, write them in the box that that's what is allowable, because that's what they use in instruction, and make a statement that says the calculator is not currently being used. Through third grade, I think that's appropriate. Again, depending on the needs of the student. So most of the kids, though, I would say starting at the end of fourth grade is when the calculator becomes pivotal. Because again, it's about leveling the playing field. And if we get into fourth grade and we're looking at standards that they have to multiply multi-digit numbers, they have to divide, they have to multiply decimals, things like that. If their access and their tool to meet that standard is going to be through the use of a calculator, I think that's okay. Do I want them to understand it? Absolutely. Do I, as a teacher, as an educator, need to be strategic with how I'm building in the use of a calculator? Absolutely. Do I want to build in routines like, you're going to solve this first, I'm going to ask you a bunch of questions, then I'm going to give you the calculator and have you check your work. But it's important for some of our students that they start working with the calculator in fourth grade, because it gets them proficient with it and they continue to use that calculator in middle school. If they go to middle school, if a student goes all the way through elementary school, never saw a calculator, and then they go to middle school and they get a calculator, they're not going to know what to do with it. And then that's when we really see a lot of impact with calculation. And it's because some of our students are still working on addition.
Say a kid with an intellectual disability and they're still working on basic adding and subtracting, but they may be in middle or high school. And how can you write a goal that then could be used in a general education classroom? How's that going to work? For many parents, that's impossible to imagine.
So we have a child who really needs to work on it, like basic number sense. They're in a middle school classroom. We want to increase inclusion, but also meet their specific needs, right? So this is a giant problem. So a couple of things that can, I think, depending on the kid, I would recommend different things. So one way to work around this problem is to write a goal focused on the standards of mathematical practice. So a goal that's more about that child's engagement in the classroom, their participation in the classroom, and like what they're doing, the how of how they're engaging, their talk, their problem solving, their collaboration, then the content. That could be the strategy that a parent wants to go with. I want everyone to focus on how my child engages in math class. But you could also have that and content goals, but sometimes you might need more than one content goal or think strategically about which you want it to be. So you could, if you want the teacher to focus on the number sense that the child still needs to develop, then I would advocate for a number sense goal, but maybe also advocate for a goal that's connected to the mathematics of the classroom. This is pretty tricky, but there are ways to connect grade level mathematics to the mathematics the child is learning. So for example, if you think about algebra, algebra has a ton of different goals in 7th grade, but one of the main ideas about algebra is equivalence. So the idea that, A plus B equals C, right? It's that it's a bunch of equations. And if you don't understand that these two sides are equivalent, you can't do any of the algebra. That's a core idea. But that idea also can be used with kids who are working on earlier grade level things. They might not be working quite on a variable, but one thing we do with kids is we'll say things like 8 plus 7 equals blank plus 1. So kids And actually, the older they get, and this is like all kinds of kids, will write 15 in there because they think the answer comes after the equal sign. They think the equal sign means the answer comes next, not that these two things are equivalent. So we do a lot of work with it's very simple addition, subtraction, multiplication, but it's about understanding that those two little lines, they mean that these two things are the same. So you can do work on basic number sense that is connected to the most important ideas in algebra. What I would say are the core ideas of algebra, which is one of them is equivalence. But like I'm saying, you can design instruction that begins, it's about number sense, but it's also about this core idea of equivalence. So this is about IEP goals, but this is also about inclusion in mathematics. It requires a lot of understanding of mathematics to do this work because you need to be able to say, okay, algebra, what is the core idea here I want this child to come out with? They're not going to understand everything about algebra in the 7th grade class, but what is like core and important? And it might be equivalence. It might be matching graphs with equations. You have to pick something that really matters, that's ambitious, that's the high leverage, right? But that requires mathematical understanding. And so sometimes that can be pretty tricky for parents and it can be tricky for teachers, which is why I continue to advocate for more professional development for special educators in math.
A lot of people, the first thing they want to do is go to skip counting.
Mm-hmm.
And that is as challenging as any counting, right? Now we're going to learn another way of counting. Whereas using a multiplication table like ties into a visual area method, right? And so are there ways that you can push towards using those kind of strategies in multiplication and division? Often people are like, well, you can't start that until you've mastered the others.
In 3rd grade, you start multiplication, you also start early fractions, and kids are often so happy in math in 3rd grade because it's like, we put those big numbers and those procedures to the side, and now we're doing multiplication, and so fresh and so new, and multiplication can be so visual for kids. There's an intervention sort of routine with multiplication that I've used with kids who need more help with it, and it is, I'll say, go make me, I give them lots of blocks, make me 2 towers of 3 blocks, 2 towers of 3 blocks, and they make it. How many blocks? 6. Then we do, make me 4 towers of 3 blocks. And then those blocks become arrays. They become columns. They support skip counting, but then if a kid needs to count by ones, they can count by ones. But if they can start to skip count, it supports the development of skip counting, like what's called an array, which is like a box, but it has to have all the little boxes filled in for kids when they start, or it has to be made out of blocks. Or we take pictures of like things in the world. Like when I worked in New York City, we used to go on little field trips and take pictures of skyscrapers and then count the windows. Because it was for some reason we found it very fun. But multiplication, so what I'm saying is that multiplication is easier for a lot of kids than subtraction. So that's why we don't hold kids back, because I've seen a lot of kids who can do higher mathematics, but can't count accurately. So as parents, we need to understand math is not a ladder where they have to understand every single thing before they move on. It is not. A better metaphor is that math is a house and some walls are load bearing and some walls are not. Certain things like number sense, understanding how digits work, like place value in a meaningful way, that really matters because kids can't know how numbers are bigger or smaller without that. That's a load bearing wall. But we have to figure out what really matters and what we can put to the side and just because we're going to keep building this house. Now in my metaphor, we're building many layers on top of the house.
But so let's talk about the idea of functional math, because that comes up quite a lot. Like people say, we want this to be functional math, or, we sometimes have added to IEPs, focus just on functional skills. And the question is, isn't all math functional?
Yes, it is all functional. And what is functional? Is it that we're still teaching counting coins, or is it that we're, teaching like, do I have enough money and I have a bank card? So I think, when I think about functional math, my brain defaults to that thinking of Like I have to teach them counting coins. I have to teach them, you know, time to the hour, like, because how do I function in life? But again, it goes back to, in order to function, like if I think about really truly what is functional math, it is functioning within our world, which is math. Like I talk to kids all the time. They're like, I hate math. I hate math. I said, sorry, kids, life is math. Math is life. You can't get away from it, no matter what you do. So you might as well make sense of it. And so I think that's my big thing is like, what is functional? And maybe it's individual. Like for a student, what is functional for that student? Is it for that student that it's subitizing? I think that's functional. If a student isn't subitizing to 3, I'd say, okay, we got to get them subitizing to 3 at least, because I want them to be able to know that instantly. So I feel like you said, I think it is all functional. And if we kind of stop saying functional and just say, what are the math skills that the student needs to develop so that they can be a stronger member of the community, or they can be independent? You know, what are the skills that the student needs that will lead to independence?